All right, it's recording. Shh. Listening. All right, so both for year 11s and 12s, you both need to know 6.4 outliers. You don't necessarily need to know the full calculations, but you do need to know what it does. So what does it do? How does it affect? So I've got a blurb at the end of the notes for you to at least keep that in mind, or when you write your notes, there's something to follow on. But let's do outliers. Today's only about outliers, nothing more. Outliers. An outlier is a value that is very far. Write this in. Shh. Thanks, team. Eyes and ears towards the board. So an outlier is a value that is very far below or above other values. So when you see it on a graph, that's the skill for year 12s. When you look at a graph, your only skill needs to be, can you tell that it looks further away from the other values? Thanks. Thanks, Pav. Let's focus. Here we go. So an example is if I gave you this list of data, we've got 2, 3, 4, 4, 5, and then I suddenly have 30. Ideally, that most of you can look at it and say 30 seems very different to the general data. Because 30 is very different on a feeling sense. You'd say that's an outlier. Okay, because 30 is very different from 2, 3, 4, 4, and 5. But the question is, where do we draw the line? Where do we draw the line to say that 30 is definitely an outlier? Is 28 an outlier? Would 25 be an outlier? Or would 20 be an outlier? At what point, if I drop the numbers down, would 10 be an outlier? Where would you draw the line to say, once you pass this number, that's an outlier? Okay, so in a general sense, if you're able to look at this and say, yep, 30 was very different, and that is an outlier, that's what they want you to know. And you need to be able to do that on a graph, whether it's a scatter plot, bar graph, bar chart, dot plot. You need to be able to tell that. So that's the skill. Okay? How do you know, or where can you be accurate about it? This is where the calculations come in. Here's the formulas for it from your exercise book. So when you're doing the formative work, this is what we assess. But at the end of year exam for year 12s, they really just want you to be able to interpret and analyze, which is the last bit of these notes. Okay, the calculation is more for formative, so to get your S's. Okay, so to get your S's, this is what you need to be able to demonstrate. Lower fence. So how do you know where the boundaries are? These are the formulas for it, and Jasper told us last time it was Q1 minus 1.5 times IQR. Fill that in if you've forgotten it. And upper fence, which means the line that you draw on the upper end, is Q3 plus 1.5 times IQR as well. Okay? So these are your upper fences and lower fences. That's pretty much what the exercise is. When you're working through them, this is what you must demonstrate as calculation for formative work. For your exams end of year for year 12s, it's about interpretation. It's about knowing what data can't you have, why can you have it, and what sort of measures can you have or why can't you have it. Okay, so that's a bit harder, which I'll explain towards the end. So any data above or below these fences is considered an outlier. So let's do an example so that you can apply this formula. Here we go. Let's say they give you a stem and leaf plot. For year 12s in the end of your exam, you should be able to look at this data and interpret it. And if I asked you which one is, like, where would the mean or median roughly be, hopefully you guys would be able to say it's probably in one of those numbers there, because that's where most of the data sit. So I expect the middle is probably somewhere in between these two. So it could be 22, it could be 26, might be 19, or might be 18. I don't know where the middle is, but it's roughly there. But what I can also tell is that 71 looks very different from the rest of the cohort. Okay, so that's the interpretive skill. The calculation, which is your exercises, is now to calculate, well, they want you to find IQR first so that you can find any outliers. So here we go. In order to find IQR, how do you find IQR again? What's the formula? Can I please have, let's go with Archie. How do you find interquartile range again? What's the formula? Ooh, that's going to be on the quiz. You better be revising that. Someone else. Olivia. Q3 minus Q1. Write this down, Archie, so that you know, so that you can do it later. Jack. It's good that I'm testing year 11s too now. Jack, what is Q3? Yeah, what does that mean? Good. So it's the 75th position. So you need to find the 75th position. Minus, what's Q1? Let's go with Mitchell. 25. Very good. So you need to find the 75th and 25th position. Subtract them from each other. Now to find the 75th and 25th, you need to find the middle first. Okay, so how do you find the middle? You got to count the number of data you have. Right now, I've got 1, 3. This now represents 10, 10, 11, 13, 14, 14, 14. You don't want to write all that out. You've already got it all organized for you. The smallest number is clearly a 1. Highest number is 71. So instead of listing it out and writing 1, 3, 10, 10, 11, 13, 14, 14, that takes too long to do. So what you're meant to do is count them. So let's count the numbers. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So I got 33 data points. 33 of them. So N equals 33. Now what was the formula to find the median again? It's all revising your your quiz stuff. Let's go with Pav. How do you find the median? What was the formula again? Yeah. Close. You got all the right terms, but you didn't say it right. What was that? Good. So it's N plus 1 for those who've forgotten it. N plus 1 divided by 2. So if we got 33, 33 plus 1 divided by 2, which is 34 divided by 2. What's half of 34? Half 34. 17. So what this means is the 17th position is where the middle is. So start counting. 1, 2, 3, 4. So I'll do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That number there is the middle. Okay, so this is what I meant by, I said that the middle had to be between these two because that's where most of the data is. And we figured out number 25, so 2 and 5, that's the 17th position. So the middle is 25. So if 17 is the middle, that means you have 16 numbers on the lower end, and that means you also have 16 numbers in the upper end. So what is the middle of 16? And what's the middle of 16? Because you're trying to find Q1. So you need to look at the middle of the lower half. Now you can sit there and list them all out, or you can count them. What was that? The 9th one. So the middle of 16 is 8. Okay, but because it's in the middle of 8 and 9, so remember the rule was N plus 1 divided by 2. So we said there are 16 numbers. So it'll be 16 plus 1 divided by 2. 17 divided by 2 is 8.5. Which is what, no, you were right. So it's between the 8th and the 9th. Yeah, so 8th and 9th. So where's 8 and 9? Here. 8 and 9 is here. So the middle is in between 14 and 14. So the number must be 14. Okay, so Q1 is now 14. Okay? Then on the upper half, because you know it was the middle of 8.5, so it's 8.5th position, so you count the same for the top end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's between 8 and 9 again. So in this case, 8 and 9 sits right here. So if it's in between the 8 and 9, it's 35 and 37. What's the middle of 35 and 37? 36. So hence, Q3 is 36. Put them together. 36 take away 14. What's that? 22? I think it is. IQR is 22. Your question, and this is the only part that you have to do as a calculation. Now you know IQR. Shh, boys, can we settle down? Yeah, I know. I was ignoring it. Just chill. Just chill. Yeah, I'm trying to teach. If you guys don't want to learn, sit there, chill. Yeah? You don't have to learn. You can sit there and chill. All right, so IQR is now 22. Your goal is to find outliers. Outliers is when you have the two boundaries and any number passes those boundaries. So your lower fence and upper fence is what you need to calculate. So lower fence was Q1 take away 1.5 times IQR. Let's work out a lower fence. Q1, which you already know is 14. 14 take away 1.5 times 22. Why 22? Because that's your IQR. Do it on your calculator. 14 take away 1.5. So that's what? 22 plus 11 is 33. So 14 take away 33 is, what is that? 16 plus 3, 19. So negative 19. All right, so if you have any numbers less than negative 19, which clearly we don't, that will be an outlier. Then you got to calculate the top end. Let's do upper fence now. Upper fence. Q3 plus 1.5 times IQR. Here we go. Q3 was 36. Plus, and I already did the calculation for you, 1.5 times 22 was 33. So any number bigger than 36 plus 33, which is 69, any number bigger than 69 is considered an outlier. And in this case, yes, we do. 71 is definitely an outlier because that was where we drew the line. We drew the line at 69. So if you're 69, you're within the data. If you're above 69, you are now considered an outlier. So therefore, outlier equals 71. So as a formative work, that's what I need to see. Okay, so in 6.4, when you guys are doing your work for the 12s, and then same thing with 11s, I'm checking because in this one skill, I can already see a lot of things. I can see that you know how to do IQR. I know that you can interpret a graph. Well, in this case, this is a stem and leaf plot. I know that you know what a median, Q1, Q3 is. That's pretty much what the quiz roughly talks about. So that in one question, I can learn a lot about you and what you've learned from chapter 5 and chapter 6. Does that make sense? Okay, so when you do your exercises, that's what I'm looking for. I want to see if you can do that. You get a calculator to do it anyway. All right, let's flip over the page. Now, example 2, I can leave that for you. You can work out what the pattern is, but I'm interested for the year 12s and year 11s. Your skill at the end of year exam is not about calculation. Examiners are interested in your interpretation. What does that mean? These are notes for year 12s. Year 12s who are planning to do exams, please focus on this section. What are the effects of outliers on the mean and median? See, when you calculate the mean, remember you said it's summing of all values and then divided by number of numbers. The problem with summing all values is that if you have an outlier, that gets included in your sum, makes your sum really large. That means your mean gets heavily influenced by an outlier. So when there are outliers, your mean changes heavily. So write that in somewhere. Mean changes heavily with outliers. That's a key point to interpret for 12s when you walk into an exam because you have to explain that. You have to understand it's because you're summing all values, which includes the outlier. Different to the median, median doesn't actually calculate the sum of all data points. The median actually ranks it from smallest to largest, and because of that, the outlier would have been the smallest or the largest, doesn't actually get included as part of the median. That's why the median doesn't get affected. So that's why median is best used when you don't have an outlier. That's literally what you have to write as a year 12 when you're identifying and interpreting. You have to say median is better than a mean because there are outliers in your data which skews the information or calculation. That's what you need to be able to say. So here, number of data points, not the, what's this? It's calculated by the number of data points, not the value of each data point. Okay, so therefore, when you have very large or small values, it can greatly change the mean. Hence, outliers can distort the mean. That's literally what you have to take out from this exercise for year 12s at the end of year if you plan to do the exam. And they give you a sense of a graph and they say describe your calculations and any limitations. The key word was limitations. You have to identify that bit. That's where you get that extra bit that most students don't get. Okay, and that idea that you know the mean gets affected by outliers, so the better measure is median. You're meant to use median. That's why study schools are calculated by medians at the end of year. If you look at each school, when they publish on the newspapers, they publish median, not average. Because average, you could have kids who are just outrightly too smart, whereas the school still performs lower. That still brings up the average. Any school that uses average is because they're trying to inflate the data. They're trying to make it sound good. Okay, so that's what you need to be able to say. Median is a better measure. Same thing with salary. When you watch the news and they say the average salary in Australia is blah, 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 the average is a bad measure because we know that there are CEOs who are earning 500K to possibly closer to 1 million. That is not where the average person is, and that skews the data. So knowing that median is the actual better measure for the center. Okay, so average, this was the one I was trying to say. The average annual salary for a full-time employee in Australia is actually quoted at least 2 years ago when I saw it, and recently they were saying it's about 100K, so 6 figures. The reality is that we know if you actually go on to any LinkedIn or you actually look at it, 90K you can expect for a full-time, usually academic route that you go on, or any sort of trades, you would be 90K and above after a few years. But as a first time coming into a job, you can expect about close to 90K depending on which field you're in. But otherwise, any part-time or casual workers, you can also expect an average of 74K. Okay, so it's median of 74K. That's roughly where we're currently sitting at. Obviously, different fields will change. So what does this mean about the median? So what does it mean if the median is lower than the average? So median is the 50th percent. But if the average is higher than the median, what does that mean? So if you think about a box plot, what I'm saying is, what happens if you find that the median, which is here, but then the average is higher? That implies there is an outlier much greater in this direction. So as an annual salary, an example, if we say that median is currently 90K for average salary, but the average, they're quoting 100K, the only reason why that's moved up is because there must be a value up here that is so high. There could be a few values up here that's pushing it up this way. That's why the average goes high, because the average gets influenced heavily by an outlier, whereas median doesn't. That's why median's lower. That kind of interpretation that I just wrote here, that's at the year 12 exam level. When you walk in, that's what they want you to be able to say. Okay? So that little bit there, this is pretty much what you got to take away. But in terms of formative, to get your S's, for those who just want an S, one of the skills I'm looking for is, can you do that? Those are the skills. Same thing with your 11s. 11s, I need to know that you can do IQR, Q1, Q3. That's what the quiz today is going to be checking as well. Okay, so your 5-number summary. All right, I'm going to pause the video there. That took me about less than 10 minutes to go through what I needed to say. You will start your quiz just about 2:40, around the 2:40 mark. Yeah, 2:40 mark will start. So you got about, say, 17 minutes to have a look at your notes on chapter 5. Get yourself ready. Get a calculator if you got one. Sorry? Which one? This bit? This, what are you talking about? His notes?